viewers, hello learners. My name is Tembele Matoti from St. John's College in Umtata. But I come to you today more wearing the cap of a Deputy Chief Marker in the National Senior Certificate exams. I want to be looking at the approach that you'll be taking when you are responding to your exams. Welcome to the ECDOE broadcast studio. Today's lesson is on tropical cyclones, particularly covering the general characteristics. Okay. First and foremost, you may notice that I have given you an image that has got the Indian Ocean. Okay. And that is the eastern side of Africa, particularly Southern Africa here. So we are going to be focusing on the Indian Ocean in the Southern Hemisphere, which is the eastern side of our coast. Okay. By definition, what are tropical cyclones? They are low pressure depressions that need very high temperatures to form, and they are associated with very, very strong and violent weather. Typical strong winds and flooding that affect the environment badly. They also affect the human population, and they affect a whole broad spectrum of activities that are associated with our geographical content. Okay. Now, I've tried to find an icon that is showing up just below the equator, often referred to in Afrikaans as the evenaar. And that icon is there to represent a tropical cyclone. You can see it's very nice and round, and then there's the center, which I hope will signify the eye. Okay. Now let's see what happens there. Look at that. Okay. Tropical cyclones originate over the oceans, but you have to qualify those oceans for the exams. They are warm tropical oceans, and even go further and say with temperatures from 26.5 degrees C and above. So you are free to give 28 degrees, 29 degrees, even 30 degrees C. But key thing, you must have the degrees and you must have the C. If you just write 29 degrees without the C, there's no mark there. The whole component of the temperature reading must also show the units of presentation. They occur along the tropics, hence they are called tropical cyclone, because they occur along the tropics. Okay, you will find them from around 5 degrees north and south of the equator and further down. In essence, you will not be able to find them between 0 and 5 degrees north and south of the equator. Reason is that they need the Coriolis force to be able to function fully. Now, between 0 and 5 degrees north and south of the equator, the Coriolis force is very, very weak. Some learners are bold enough to say the Coriolis force is non-existent, but I would recommend that you say the Coriolis force is very, very weak. Okay? Okay, let's take the next one. Tropical cyclones move from east to west. Okay, they move from east to west. What is the reason for that? Because the examiner is often very, very interested in that. Okay, because they are carried by the tropical easterlies, or you can say they are in the tropical easterly wind belt. Okay, or you can say they are carried by trade winds. But that's also a common term, especially coming up from grade 11. They're called trade winds. Okay, let's see. There's the icon. But something is happening now. The arrow is starting to bend, meaning they don't simply move from east to west, but they also move, look at that, away from the equator. There's a reason for that. And the examiner is also interested in that. Okay, remember that the Coriolis force affects any wind or any air that moves. Okay, so in the southern hemisphere, it will deflect it to the left. In the northern hemisphere, it will deflect it to the right. So this is east to west and away from the equator. Please be geared to be able to explain that, because it is going to be part of your higher order question, where you are asked to reason things out. Okay, then look at that. In the eye, you get a very, very particular weather. In fact, let me move on from particular and say peculiar, meaning unique to the eye. Okay? In the eye, it will be windless. There'll be no wind. Okay? In the eye, it will be rainless, meaning no rain. And in the eye, it will be cloudless, meaning no clouds. Please, learners, don't romanticize geography. Windless is not the same thing as less wind. Rainless is not the same thing as less rain. And cloudless or no clouds is not the same thing as less clouds. Less clouds is wrong. Cloudless is correct. Okay? Rainless is correct. Less rain is incorrect. So please be careful about those things, because in the exams, we're looking for the correct scientific articulation of what happens there. Okay? So that is the unique weather in the eye. Then the cyclone continues to move from east to west and away from the equator. Here it hits the island of Madagascar. Okay? Remember, we often say tropical cyclones die over the land. Two things, two-pronged. We say they originate over the oceans, and we give reasons for that. Okay? Very high temperatures over the oceans, enough evaporation, and there's sufficient latent heat, and there's enough moisture support. There's less friction. Now, twist that and say they die over the land. It will give you the opposite of that, because there'll be less evaporation over the land, and there'll be less moisture support, there'll be less latent heat, and there'll be more friction. Okay? So once it hits Madagascar, the tropical cyclone has got a chance to die. But often, if it is strong enough, it moves over to the warm Mozambique Channel, where it regains the energy. Remember, it is the warm Mozambique Channel. Okay? There is warm water, and there is warm water vapor emanating from that, giving energy and the ability for the tropical cyclone to spin itself. So heat is energy, and energy is the ability to do work. There's your physics coming in, and geography is physics. Okay? Once that cyclone keeps moving, okay, it will now move over the warm Mozambique Channel and hit the continent, the landmass. It attacks the eastern seaboard of the countries. Okay? Now what happens there? There'll be destruction. And there are two reasons why tropical cyclones are deadly. They are destructive. Reason number one is that they have got very strong winds. And those strong winds are damaging to the environment. They are damaging to the built environment. They are damaging to the shoreline along the coast. And they are damaging to anything that it comes across. Okay? And also, there's torrential rain, heavy rainfall that brings flooding. Okay? So those two things are the key elements that create damage when you're talking about tropical cyclones. Let me repeat: strong winds and very heavy rains. Learners, in the exams, don't just say rainfall. Mention the rainfall and qualify it. Heavy rainfall or strong rainfall. Or you can say a lot of rainfall. Or you can say torrential rain. But we are looking for that qualification of the type of rainfall. Okay? There it moves. Something happens now. You can see it no longer moves from east to west, but it turns and moves in the opposite direction. And the examiner gets interested in that. Okay? Where does that happen? Around this area here, you will get a 30-degree line of latitude, meaning that you are now moving from another pressure belt to another pressure belt. You are moving from another wind belt to another wind belt. So from 30 degrees to 60 degrees, you've got the westerly wind belt. So these start changing direction and moving from west to east, meaning they are carried by the westerlies. Please note that, because the examiner is very, very interested in that. They are carried by the westerlies. And the westerlies move from west to east. Remember, the winds are named according to where they come from. From west to east, they're called the westerlies. And the wind belt is the westerly wind belt. Okay? Look at that. Turns east at 30 degrees. Please, dear learners, be ready to give the reason behind that. Meaning they are carried by the westerlies. Okay? Often you find that the latitudes that are higher there, being the tropics and so on, are much warmer. And as you move further down, the latitudes get cooler and cooler. The further away you move from the equator, the cooler it becomes. So in this area or around this area, there's a possibility that the tropical cyclone may dissipate, meaning it may decay and die, meaning it may come to the last stage of its life. The life cycle will come to an end and dissipate. Reason being, these latitudes being colder as you go down, it means they'll have less moisture because cold oceans don't have evaporation capacity as much as warm oceans. So there'll be less moisture and there'll be no warm air, and therefore there'll be reduced latent heat, meaning the heat that it was using to rotate or circulate will no longer be there. And there's also the possibility that, learners, remember that when the cyclone hits the land around the area here of South Africa, Lesotho, Swaziland, as you can see my circle here, there'll be more friction. So that's also a reason for the cyclone to dissipate, because more friction leads to an increased drag effect. It starts pulling the cyclone down, slowing it down, and it might also die in that condition. Okay? So let's move on to the next one. I'm now bringing in a synoptic weather map. Okay? One thing I want to highlight here, look at the date. Okay? 1994, 18 February, meaning this is actually late summer. And that season is typical of the formation of tropical cyclones in the southern hemisphere. 1994, February. February is late summer in the southern hemisphere. Okay? Other things I want to highlight here, in line with the general characteristics, are that there is the symbol at the center, and that symbol is the symbol of the eye. So you have to be able to identify the tropical cyclone on a synoptic weather map by looking at the symbols. And that one symbol there is that represents a tropical cyclone. Okay? Here's what I want to see again. Julita. So tropical cyclones are given names. So the tropical cyclone season will have names starting from alphabet A right through to the last alphabet, which is Z. So they are named alphabetically as they form over the ocean, not when they hit the land. Okay? As they form over the ocean, not when they hit the land. So Julita is a cyclone that was named with an alphabet J, meaning there's A, B, C, D, E, F, G, H, I. Then there are 9 cyclones that occurred before Julita, and Julita is the 10th cyclone. And I'm sure we can relate to this in terms of your trial exam question paper 2025. Okay? Now, you can see clearly here that the weather stations around the eye have got a lot of cloud cover, meaning there are clouds, heavy cloud cover that are around the eye. Look at the temperatures. Maybe not very clear, but that is 28 degrees there. Okay? That is 28 degrees there, meaning the temperatures are very, very, very high. Okay? Now, the isobars, the lines that join places with the same atmospheric pressure, are also round or concentric. Look at that. Concentric, meaning they are representing a tropical cyclone. Okay? Let's move on to the next one. Okay. I want to bring an image from the television. Okay. Because when you watch TV, it mustn't be for fun for a geography student. The weather report must talk to you as a geography student and pick things that are important to you, that are applicable to your studies. Okay? My area of interest here is the warm Mozambique Channel. Okay? Remember, that's a tropical depression relating to the tropical cyclone. And look at the movement. Tuesday to Wednesday, moving from east to west. And if you can draw a line here and draw another one here, you can see that generally this moves away from the equator. So it fits everything that we have had so far. And there's Madagascar, the island that often protects us. If the cyclone hits Madagascar and dies, it means we don't have to worry about what happens after that, because it won't reach the mainland of the African continent. Okay, I want to look at Cyclone Idai, which was also in the exams a few years ago. It's not the same as what you see on top here. What I want to highlight here is that with Tropical Cyclone Idai, you've got a lot of information that is shown there that you can relate to. The wind speeds are very high, okay? Gale force winds, okay? And the speed is 8 miles per hour, which is fairly high in terms of geography terminology. Something else I want to highlight. This is the southern hemisphere. You can see Mozambique, here, okay? And the whole towns, Chirola, okay, Beira, those are towns in the southern hemisphere. So you can clearly identify the hemisphere from there. Madagascar is the island in the southern hemisphere, okay? Now, I want to take something. Remember, dear learners, we are dealing with general characteristics, okay? When we started the lesson, we spoke about low pressure depressions, okay? And a low pressure in the southern hemisphere has got clockwise circulation. How do we pick that clockwise circulation here? Listen to this, because you're not going to get it on the textbooks, okay? Grab the tail. We start at X, given in the X. Follow the tail to the center. And if you look at my finger, it is moving in a clockwise circulation. Look at that. Take the X. Follow the tail to the center. That is clockwise circulation. Put an X there. Follow the tail to the center. That's a clockwise circulation. So tropical cyclones have got clockwise circulations in the southern hemisphere. Keep that. That's very, very important. And it's going to be definitely one of the interesting points for the examiner. So keep that in mind. Cram it if need be, but I'll prefer you understand it, okay? Low pressure centers have got clockwise circulations in the southern hemisphere. That's a satellite image that was recorded then live. That was in 2002, 21 to 23 January. And clearly you can see the movement being east to west and away from the equator and attacking the continent of Madagascar, okay? That's a satellite image from Meteosat, and it shows you a whole lot of elements. But I'm more interested in, you can see the eye, very clearly articulated at the center, and you can see the cloud cover, which is heavy cloud cover, cumulonimbus clouds. We accept only the example of cumulonimbus clouds when we are talking about heavy cloud cover, okay? Please don't give the code, give it in full. Cumulonimbus cloud. Cumulo, shaped like cauliflower, and nimbus, taken from Latin, rainfall. So those are rain-producing clouds. Cumulonimbus, cumulonimbus clouds, okay? Now we move on. We're going to take the November, December 2024 question paper, and we're not going to attempt all the questions, but just try to clarify what is happening there. And this has proven to be quite a challenge in the previous 4 years for our learners. What you see here is called an infographic. Okay? There are about 7 ways of presenting information to learners. So once you use a combination of 2 or more of those ways, we call that an infographic. Okay? So here, for example, which ways have been used? Okay? Here we have used an extract. There's a text. Okay? And here we have used an image, that is a figure. Okay? Here we have used a drawing. Okay? And we have also used a table. So there are 4 ways that we have used to present the data or the information to the learner. Now, my advice to you learners is start by reading the text. Make sure you understand the text, and then take one of the other ways of presenting information and relate the text to that and see if it matches. Because you've got to find a match. Because the text must speak to the image. The text must speak to the drawing. The text must speak to the table. Make sure you find common areas and common understanding amongst those sources of information. Here we are looking at whether the learner can extract the information from the text or from the image or from the drawing or from the table. That is the skill we want to see from you, extracting information from the infographic. The good news is that 25% of the marks that we are going to be allocating are marks that are directly obtainable from the infographic. So you are pretty sure of getting information from there if you know how. So we need to drill you on that as we move along. Okay, let's see what is happening here. Let's read the text for once. Okay, the tropical storm made landfall in Mozambique, and the date is given 12th March, after strengthening off the coast of Southeast Africa. Now, the next 2 things are also very important: bringing strong winds and heavy rain to Mozambique. Remember I said, it's not just rainfall, it's not just winds, strong winds, gale force winds. Rainfall, you qualify, heavy rain, torrential rain, a lot of rain. You need to mention and qualify, okay? And then the dates move. We were talking about the 12th, now we are talking about the 13th. On 13th March, Tropical Storm Filippo, they're named alphabetically. Tropical Storm Filippo moved back over the ocean and developed into a tropical cyclone on the 14th March, meaning it was developing and getting stronger and stronger. Okay? Now, if you look at that information and match it with the table, you will see that from the 10th to the 11th, there was an increase in wind speed, meaning the cyclone was getting stronger. Okay? And look at the 14th March, and then it was classified as a tropical cyclone, meaning the wind speed was even higher than the previous days. So you can see there that the cyclone is actually growing, developing, and becoming stronger. So what you are hearing about here is actually the same as what is said there. Okay? So now let's look at the movement. Okay? 10 March, okay, east to west and away from the equator. Okay? And that is the southeast coast of Africa, east to west and away from the equator. And then around 30 degrees, then there's a 10. I can say clearly this matches our previous frames, but we are now applying the information to the infographic. Okay? So let's see what our questions are all about. State one condition that could have led to the development of Tropical Cyclone Philip. Now, this one condition out of about 6 or 7, remember we said they originate over the ocean, and we gave conditions. Warm tropical oceans, 26.5 degrees C and above, lots of water vapor, lots of moisture support, and also latent heat. And remember, with increased condensation, you also get more heat released back to the atmosphere. So there's a lot of latent heat. Heat is energy, and energy is the ability to work, okay? Less friction over any one of those can give you marks. Remember, that's only a 1-mark question. anyone. Okay? Now, 142, give evidence from the map and the table. Now, this is how it becomes tricky. Not only from the map, but it must also be from the table. So we need two sources of information to qualify. Hence, you have two answers, there we go, of 1 mark each. Okay? So if you give me only one answer, you're shortchanging yourself. You give me two answers of 1 mark each. Okay? So look at that. I'll bring in. Okay? Look at that. Here we have exposed to moisture over the ocean from the 10th to the 11th of March. It was over the ocean. It was exposed to moisture. And also on the table now, wind speed increased. Look at that. I'm circling it again. So you've got two sources, and the examiner is telling you exactly where to get the information from. One from the map, and the other one from the table. Okay? And then I'll take 143. Give two reasons for the decrease in wind speed. Decrease in wind speed from 6 in the morning to 18 hours on the 12th March. Okay? Now let's see what happens here. Okay? The cyclone moved over the land. Remember, over the land, there'll be less moisture. We have dealt with that. Why do tropical cyclones die over the land? Over the land, there'll be less moisture. Okay? Increased friction, meaning there'll be friction drag over the land. Okay? And less latent heat. Why? Because there's reduced moisture support. There's less evaporation, and therefore there'll be less condensation, and therefore less latent heat. Okay? And then the cyclone itself will have less energy to be able to spin around, and it will dissipate, it will start to die. It will reach the end of its life cycle. Okay? I'll take now 144 as my last question. Okay? 144 is very, very clear on what the examiner wants from you. You have to draw, okay, a labeled or an annotated drawing showing a cross-section of the mature stage, that at which Filippo is. And what do you do with that cross-section? Marks will be allocated for 1, the cross-section itself, okay? 2, the cloud type. 3, the eye. And 4, the air movement in the eye. Now let's look at the picture here. 1 mark is allocated for the cumulonimbus cloud. Remember I said, write it in full. We don't really entertain the symbols because we have to label so that anybody else can see what it's all about. Remember, CB is a code. It's a code. We want full annotation. Cumulonimbus clouds, okay? And then we want you to show us the eye, which is the center of the storm, the eye, okay? And also show us subsiding air, which is the air movement in the eye, subsiding air, okay? The air movement in the eye. And then if you look at the general image, you can see that there is the center, there is the eye wall, and the cumulonimbus clouds. The look of the cross-section tells me that the learner knows what he or she is doing. And I'll give you a mark for the cross-section as it looks. It may look like 2 fat cooks, it's okay, but I must see that something is happening there and it's happening the right way. And I'll be able to give you a mark. We understand that not all learners are good at drawing, but try, do your best. Make it look like it's supposed to look. Yes, there is the last question, learners, but I want to leave it there for now. We have come to the end of our lesson. You can leave your questions, your comments, or your thumbs up on our comments box. Don't forget to leave the name of the school so that we can give shout outs to your school. Please share, recommend, and subscribe to our YouTube channel, ECDOE Broadcast Studio. And thank you for watching. And please remember, this is your last chance. 12 good years of schooling. This is your last chance to make it big and earn a certificate. Study hard. Remember, the warmer the blankets, the colder the future. See you next lesson, and good luck. Thank you very much.